Hello, we're going to talk about how to graph a rational function, and we start with the example f of x equals 2x squared over x squared minus 1. We'll go down the list to the left and start with the top one, the x-intercepts. You always look to see what takes the numerator to 0. We have 2x squared in the top, and so if x is 0, then the numerator is 0. Therefore, we have a point 0, 0. Then we go down to the y-intercept. The y-intercept is when x is 0, so find f of 0. We plug it in, and we find 0. And then we realize we already had the x and y-intercept when we found the x-intercept was at the origin. Next, we move on to the vertical asymptotes. For the vertical asymptotes, we ask this question: what takes the denominator to 0? In this particular case, we see that x squared minus 1 is a difference of squares, so we can factor that. We keep the top the same, and the bottom factors to x plus 1, x minus 1. What takes each factor to 0? Negative 1 and positive 1. So we have two vertical asymptotes, two domain restrictions, x equals 1, and the line x equals negative 1. We keep on going down to the horizontal asymptote, and we throw away the noise. We look at only the highest power of x on the top, on the bottom. We simplify and we get 2, and we have our horizontal asymptote f of x equals 2. Now we're going to write all of the factors of our function in a sign chart. The top factor is 2x squared, x plus 1, x minus 1, and then we'll look at what overall the sign of the function is. We look at all the breakpoints associated with those factors. The breakpoint of 2x squared is 0, the breakpoint of x plus 1 is negative 1, and the breakpoint of x minus 1 is 1. So then we look at it factor by factor, and we say on the top, if we take any number and we square it and multiply it by a positive number, it's always positive. We look at x plus 1. The factors, the root associated with x plus 1 is negative 1. To the left of negative 1, it is negative. To the right of its breakpoint, it is positive. Similarly, x minus 1 has a breakpoint at positive 1. To the left of 1, it's negative. To the right of 1, it's positive. We look at the sign of f of x overall, and now we look at each individual section of the graph. If we look at to the left of negative 1, our sign analysis said that f of x is positive. So it can't be negative, so we will highlight that area to know that we can't go there. Similarly, we look between negative 1 and 0, and our function is negative, so it can't be positive. We're blocking out that area because we know that there will be no points there. From 0 to 1, we know that our function is negative, so it can't be positive. From 1 on, we know that our function is positive, so it can't be negative. So we know that the only possibilities for our curve to exist is in the unshaded areas. So let's look at some specific points. We notice that we have a function that has only x squared terms for the variable. Therefore, we expect symmetry, and the symmetry we get about this one is about the y-axis. And so we get 2 points for 1. So I'm going to try plus or minus half, and we can see that we get negative 2/3. It's good that it agrees with the area of the curve that is no shading. Maintaining the idea that we have symmetry about the y-axis, let's put in points plus and minus 3. You can see that plus or minus 3 for x has a height of 9/4. So we plot those. Let's get a little bit closer, and let's do plus or minus 2, and we would expect that to be a little bit higher than plus or minus 3. And we can see that if we sub in plus or minus 2 for x, we get 8/3. So 2 2/3 is definitely higher than 2 1/4. Not very much though. So let's put in a fraction. Let's put in plus or minus 3/2 and see what we get. We once again expect plus or minus 3/2 to be higher. After doing that, we see that it's 18/5. So now we can finally write the domain and range. The domain's fairly simple. All we have to do is exclude the vertical asymptotes. The range we have to be a little bit more thoughtful for. We can see that it starts off at negative infinity and goes to 0 inclusive, but then we can tell from this graph that there's nothing in between 0 and 2. So our next interval for the range would be 2 exclusive off to positive infinity. Okay, that's all.